All right, let's look at this example. Find the intervals where x cubed plus x is increasing or decreasing, and find any local max or mins. All right, so let's do that. My derivative is going to be f prime of x is 3x squared plus 1. Now, if I set that equal to 0 and solve, I get 3x squared equals negative 1, and so this thing has no solution. Well, what that means is this function has no critical numbers. So if I do my chart, I don't have anywhere to cut it up because there's no critical numbers. So I can pick any test value I want at all. I'll pick 0 because it's my favorite number. It's easy to plug into things. F prime of 0 is going to be 3 times 0 squared plus 1, which is 1, which is positive. And so that means that my actual function is going to be increasing everywhere. So this function is increasing on everything from negative infinity to positive infinity, and it has no local max or mins. And what's that function look like? Well, if we look at it on Desmos, the f of x is x cubed plus x. It looks like this. So yeah, this thing, it's always increasing. And if we look at its derivative, notice the derivative is always positive, which is exactly what our little chart told us over here. So that's not a very exciting example, but it does kind of get the point across. Let's look at 103. This one's going to be more complicated. Find the intervals where this function is increasing or decreasing, and find any local max or mins. We'll tell you what, we don't need to, but I want to put this into Desmos to begin with. I just want to see what this looks like. We got x squared e to the x. So it looks like that. So that's going to be interesting. It's got looks like it has a max and a min there, but let's do it by hand. All right. So the derivative is going to be y prime is first times derivative of the second. That's going to be e to the x over 2 times 1/2 plus the second function times derivative of the first. All right. Now I could just set this equal to 0 and solve, but the easiest way to deal with this is going to be to factor it as much as I can first. Now both of those terms have an e to the x over 2, and both of them have an x. So let's factor that out. X times e to the x over 2 times, let's see, over here that leaves us with an x and a half. So 1/2 x. And then over here leaves us with a 2. So I'll take this thing and set it equal to 0. Now, we've got three things multiplied together here. We've got x times e to the x over 2 times that. So you set each one of these equal to 0, you get x equals 0, you get e to the x over 2 equals 0, and you get 1/2 x plus 2 equals 0. So this gives me critical numbers of 0. This has no solution, so that gives us no critical number. And the last one gives you, let's see, 1/2 x equals -2, so x is -4. Something's up. This is 4. That doesn't seem to match. Going back to my going back to this, it looks like we should have a critical number at 0 and at -2. So let's go back and see, somewhere in here I've got a mistake. Let's see. First times derivative of the second with the chain rule, plus second times derivative of the first, factored out the x, factored out e to the half, x over 2. Left me with a 1/2 x. Left me with a 2. All right, so 1/2 x plus 2 equals 0. Take 2 off of both sides. I get this. This gives me x equals -4. I know exactly what's wrong. Nothing is wrong with this. It's my graph that I did that was wrong. I forgot to put my x over 2. There. All right. So let's do our chart. The graph kind of gives it to us, but I want to do the chart. Chart says, let's see, draw this. I'm going to do it in purple. So let's see, we've got to cut it up at 0 and at -4. When you put your numbers on the real number line, be sure to get them in the correct order. Usually that's not a problem, but sometimes if you got some negatives and fractions and stuff, it happens sometimes people get them in the wrong order. So just make sure you've got them right. All right, got to pick a test value. I'm going to pick 1 over here, -1 here, and back here I'm going to pick -5 would be one option. I'm going to go with -10 just because I think it'll be easier to plug in. So f prime of, my function up here was y, but I'm going to also call it f of x. So f prime of -10, when I plug that into my f prime, I get -10 times e to the -10 over 2 times 1/2 -10 plus 2. So this is negative. E to the -10 over 2 is positive. And then this is going to be -5 plus 2, which is negative. It's not -1, but it is negative. So altogether, that makes this positive. F prime of -1, when I plug that into here, I get -1 times e to the -1/2 times 1/2 -1 plus 2. So I've got a negative, e to the -1/2 is positive, and then this is 2 minus 1/2, which is positive. So you multiply this out, you get something that is negative. And then f prime of 1, I guess I can actually do that up here on this page. F prime of 1, you get 1 times e to the 1/2 times 1/2 plus 2. So that's a positive times a positive times a positive. So we get this. So this is f prime. And so my original function f is going up, down, then up. And so for my intervals of increase, it's increasing on -infinity to -4 and on 0 to infinity. And it's decreasing on -4 to 0. And it's got a rel max at x equals -4 and a relative min at x equals 0. All right.